So just like when you're working with integrals, you've got in your brain, you have a bunch of integral formulas, right? You have a bunch of derivative formulas. Well, you got to have your series. You got to start getting those things together up here. So what we're going to do is just review kind of what we've talked about so far. Okay, this is some of the convergent series we've learned about. Okay, we learned about the geometric series. You want to make sure that over the weekend, over the next couple of weeks, you start getting this down. When your series looks like that, it's geometric, and we do know how to get the sum. We worked on that on Monday. Does that look familiar? Okay. If you have a geometric series, you can get the answer by doing a over 1 minus r. Okay, we learned that. Okay, we just learned the p-series. If the p-series is greater than 1, then it's going to converge. So an example would be like if you had 1 over k to the second, that series converges. 1 over k to the 11th, that converges. Real simple. Telescoping, we talked about telescoping last time. Okay, and that's going to be series where you tend to have a difference of a term and the next term, like that. That's going to be telescoping. Remember what happened on that is we wrote the terms out. We were left over with what? The first term and last term, with all that cancellation. You kind of remember that? That was called telescoping. I haven't talked about this one yet, but we'll kind of talk about the factorial. That's another common converging series. Okay, we also have this, the geometric series. We know that it only converges when that common ratio is between -1 and 1. We worked on that last time, so it will diverge in that case. P-series, we just talked about that. That's going to diverge when p is less than or equal to 1. So if you had 1 over k to the 1/2, that's going to diverge. And you want to try to get fast on these things with identifying. Oh, I got a geometric, I got a P series, I got telescoping. That's your goal. The other one is harmonic. We learned that last time. That one also diverges. Okay, and then we just worked on the divergence test. So this is just sort of a summary of what we looked at so far. So this is kind of good to begin to get this in your mind so that you can recognize these things. Okay, let's work a little bit with factorials. And I introduced the idea of a factorial today. So one of the things that you want to get comfortable with for the ratio test, because you're going to work with these factorials a bunch, is how to write this out. So if you had just general n factorial, how do you do a factorial? What you do is you write the first term, whatever it is. Whatever that number is, you write it. So you'd write that. What do you do to get the second term? Well, you subtract 1 from that number. How do you get the third term? You subtract 2. And you do that infinitely forever, and eventually you get to 1. Okay, like that. So you want to make sure you know how to write the formula for n factorial. Does that make sense? Okay. Now remember, factorials get big real fast. So over the weekend, if you're bored, get your calculator out. And I think if you get up to about 69 factorial or something like that, you'll still get an answer. But once you get after that, it'll overload, because it just gets big fast, okay? It gets way out of control. All right. So let's go ahead and let's do a couple of ratio test examples to finish this up here today. And on the ratio test, what this is really saying is if you have an infinite series, all the terms are positive, then we're going to do a ratio. Now what this a sub k plus 1 over a sub k means is it really means it's a ratio of some term. It's just some term, any term really. And then the numerator is just the next term. So what you're always doing is you're seeing how a term relates to the previous term. That's what the ratio test is. So you're doing a ratio of those two terms, like that. And it turns out that when you do the limit of this ratio, this is how you establish the convergence. If the value of this limit is between 0 and 1, including 0, then it's going to converge. Otherwise, it's going to diverge. If r is greater than 1, you're going to diverge. And then the 1 is the weird one, where it's going to be inconclusive. Okay? So one of the things I want to kind of do on here just a little bit is to introduce you to this is we're going to go back to the previous page and let's just pick something that we know that converges. So let's keep it pretty simple. Let's look at something like, let's do this one actually. I want to do this one right here. This one converges. We haven't looked at this yet, but just to illustrate the ratio test, I'm going to pick this example right here to show you then. Okay, so let's write down this series. So we're going to go k equals 1 to infinity of 1 over k to the infinity. Now that's one of them that I'm telling you that converges. Okay. All right, one of the reasons that this converges, just sort of a general way to think of this in your head, is remember I said k factorial gets way out of control fast. So what you're going to find is what you're doing is you're really doing 1 over whatever these factorials are, and it's not going to take too many terms until you end up getting to those terms are starting to go to 0 at the end. Okay, so that's kind of how that goes. So here's what you do on the ratio test, is you want to do the limit as k goes to infinity, and you want to do this like this. You always want to just write down whatever sequence I gave you. So I gave you that. Then you're going to do the next term in the sequence. So what you do is you just write the same thing, but what you're going to do is you're going to make the k go up by 1. You're going to go to the next term in the sequence, so you're going to have k plus 1 factorial like that. Okay? That's how you always set up the ratio test. Whatever I give you goes in the denominator. Okay, keep it real simple. That goes there, and then what's the only difference between the top? K became k plus 1. So get that in your mind. Nothing to it. That's what ratio test is looking at one part of the, one element of, or one member of the series and relating it to the next one. That's what you're doing. Now, the rest of this problem is some algebra. So what we're going to do is we're going to write this like this. We'll have the limit as k goes to infinity. We are dividing fractions. Okay, just do this in your head and tell me if you follow what I'm doing. What I'm doing is I'm dividing by a fraction, right? So when you divide by 1 over k factorial, what do you really do? You multiply by the reciprocal, right? So you're going to multiply like that. You'll do this so much on the ratio test, you'll begin to just do this in your head. Okay, so what we have then is we have the limit as k goes to infinity of k factorial over k plus 1 factorial like this. So I want to kind of get through this factorial stuff a little bit today because we're going to be doing this a bunch in this section next week. Okay, what our goal is we're going to look at what the value of this limit is. If it turns out to be between 0 and 1, not including 1, including 0, then we know it converges. I already told you it converges, so let's find out how this would work out. So what you want to do when you're dealing with factorials is you want to try to write these things out. Okay, and this is what you got to get solid on. So if you do k factorial, what do you do? How do you do a factorial? You do the first term, and then what do? You just keep subtracting 1 over and over and over again. So you write this out as k, then what? K minus 1, then what? Okay, you do it a couple of times until you're convinced, okay? Then you just put some dots there, okay, like that, okay? Now, we're going to go to the bottom. Watch the bottom carefully. Sometimes students don't catch on to this the first time. What do you do when you do a factorial? Step 1 is to do what? Write down whatever you have, right? So what that is k plus 1, correct? Now what do? You go down 1. So what would be down 1 from k plus 1? It would be k, right? Then what would be down 1 from k? K minus 1. There you go. Okay, you got to make sure that you know how to do that real effectively. Does that make sense to everybody? Okay, always write the first term and then just make them go down by 1. Now what do you see happening, if anything? A lot of canceling, exactly. Boom, 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 like that. So it looks like what you're going to end up with is you're going to have all those cancellations of those terms. It kind of reminds me in a way of a telescoping series in some way. So you're left with k minus 1 over k plus 1, like that. Okay, do you guys know what the value of that limit is, just like that? 1. How come? You can think of a couple of things. You could do L'Hopital's rule if you wanted to, okay? Or you could just say the degree of the top and bottom are the same, right? So basically, it's like a horizontal asymptote at 1 over 1, okay? What's that?
That K minus 1 cancels. You crossed it out on the bottom.
Oh, I crossed out the wrong thing, didn't I? Oops, okay. So let's see. I've got the K's cancel, and I've got that, okay? I was doing that so fast. Okay, so what am I left with? 1 over K plus 1. Okay, what's the value of that?
0.
0, okay? All right, so what we end up having on this is it does converge because we're equal to 0, okay? So our conclusion is we would say by the ratio test, then we would converge, okay? Yes?
So, like, because you have that extra term, does it effectively get negated because it's going to infinity?
Mm-hmm.
It's like if that series is going to like 10, you would have that extra term on top, right?
Yeah, but you know, eventually everything, you just keep going out. Everything's going to cross out except that K plus 1.
Last term, but because it's infinity.
Right,
okay.
Right, because you can always get that one more term because you're going on forever, okay? All right, so that's kind of how the ratio test works. Let's do one more of these to finish up. So let's look at, I'm going to go to the previous page, and let's pick something that we learned something about. We could do like the harmonic series. Let's do the harmonic series, and let me show you how the ratio test would apply to that, okay? All right, I'm going to kind of keep it simple on this. So let's write down the harmonic series was the series k equals 1 to infinity of 1 over k. I've already told you that diverges. Now, one of the things that, this was one of the ones that was proved back in the 1300s. It wasn't proved this way because nobody knew about the ratio test. He did it in an algebraic way. So what we're going to do is R is the ratio, and that's going to be defined to be the limit as k goes to infinity. And then what you do is you do 1 over k goes in the denominator. Tell me what goes on top. 1 over k plus 1, right? That's it. That's how you always do the ratio test, is write down the sequence there, and then the top is just going to be the next term. So change the k to k plus 1. Okay? So what we're going to end up having is we'll have the limit as k goes to infinity. And again, what you're doing is you're dividing by 1 over k, right? So that means you're going to have 1 over k plus 1 times k over 1. Okay, like that. So that's going to give you, from there, that will give you R is equal to the limit as k goes to infinity of k over k plus 1, like that. Okay? All right, now what you end up having on this one then is if you go through and do this, what would that limit give you? That would give you 1, wouldn't it? Right? Okay? You got the degree of the top and bottom are the same, or you could do L'Hopital's rule, the derivative of top and bottom is 1, so you get 1. So what that would say on this is that would say it's inconclusive, okay? The ratio test actually on this would be inconclusive, so you would have to go somewhere else to figure out the harmonic series. And the harmonic series can be proved to be divergent by doing the integral test, actually. That's the simplest way to do that. Okay, so all I wanted to kind of do today was get you comfortable with what you're going to be doing on the ratio test. It's a very powerful test, and it's very simple to apply. You always just form that ratio and then do that limit. That's going to be the idea. Okay, that's what you got to look forward to next week.